All right, so let's conclude that investigation and summarize the three ways in which a limit fails to exist, and one of them does have to do with this particular kind of fan called an oscillating fan. All right, so the first way in which a limit fails to exist is different left-right behavior. So when we informally defined a limit, we said that the function had to approach a unique y value, which we called L, from either side of our x value. Unique means one and only one, and this one approaches two different ones. So this is a very strange function. F of x is equal to the absolute value of x divided by x. We'll see where that equation comes from in Chapter 2, but for right now, we'll just use it as an example to illustrate this particular reason why the limit does not exist. So to understand this graph, absolute value, of course, one of the ways to think about it is that it always makes your number positive. So if your number is already positive, if x is already positive, this absolute value does nothing, and you have x divided by x, which is just 1, which is why on the right side here you just get 1. Okay. However, if your x value is negative, I would have a negative number down here. The absolute value would chop off that negative, and you have x divided by negative x, essentially, which gives you negative 1, which is the bottom half or the left half of this graph. And then we have open circles here at 0 because we would have 0 over 0, which is undefined, and it's the indeterminate form. So in turn, when we look at approaching x from the left-hand side, we can see definitely that the graph is getting closer and closer to negative 1. On the right-hand side of 0, it's not approaching negative 1, the same number, it's approaching positive 1, two different values. And so we would say that since f of x does not approach a unique value from both the left and the right side of 0, then the limit as x approaches 0 of the absolute value of x over x does not exist due to behavior that differs from the left and the right. When I write this down, let's say it's on a free response question, I would write the limit d&e standing for does not exist, but never ever put a little equal sign in there because we don't want to say that it's equal to does not exist. That doesn't make sense. Now, I'd also want to follow it up with the reason at which this thing fails to exist, and I can just say as simply as differing left-right behavior. So there's the first one, differing left-right behavior. The second one has to do with unbounded behavior. Here we have a vertical asymptote on the graph of f of x is equal to 1 over x squared. So from both the left and the right side of 0, x equals 0, we can see that the function is increasing without bound. F of x is approaching infinity. And infinity is not a unique number. It's not a number at all. It's just the idea that something's getting larger and larger without bound. Since f of x does not approach a unique value from the left and the right of 0, we're going to say that the limit as x approaches 0 of 1 over x squared does not exist due to unbounded behavior. And we have some special notation for this one. We can say that this limit equals infinity. That's a very strange thing to say, but it's a notation to that the implication is that this limit does not exist due to differing left-right behavior. If it decreased without bound, if it went down to negative infinity, then I would just put an equals negative infinity. Right? Now, understand that even though there's an equal sign in here, we're not actually saying that it's equal to infinity because that's impossible. It's just saying that this limit is approaching infinity, positive infinity as x approaches 0. So there's the second reason, unbounded behavior. And then the third one, very, very strange, this is the one that the fan has something to do with, and that's oscillation. So we have the graph of f of x is equal to sine of 1 over x. We graph it as we approach 0 from the left and the right, x equals 0. The graph does something that looks sort of like a seismograph. It just bounces back and forth. It oscillates between positive and negative 1 an infinite number of times. And so we can definitively say that since f of x does not approach a unique value from the left or right of 0, the limit as x approaches 0 of sine of 1 over x does not exist due to oscillation. And so just like that first one, I would write d and e for does not exist, and then follow it up with a reason like oscillation. In the next couple of videos, we'll take a deep dive into these three specific reasons. So remember that a limit fails to exist, number one, if you have differing left-right behavior. Number 2, unbounded behavior. And then 3, we have oscillation.